Welcome back to the next topic, students. Crystal field theory, CFT also we used to call it. The metal and Lagrange bond. Metal and Lagrange bond to be ionic arising dot purely electrostatic interaction. So that is N plus and this is X minus. So already told you metal always acquire plus charge. Only other elements will getting the minus. So ion-ion interaction, plus ion and the negative ion interaction between the metal ion and the negative ligand. Ligands we can consider as X minus. So X minus is extra electron donated to the central metal. So here, for example, ammonia is though it is a neutral ligand, it has nitrogen one lone pair, it has a negative minus, all H plus or a positive, and this is called dipoles, and this is a ion or the interaction between ion and a dipole between the metal ion and negatively charged end of the neutral ligand NH3. So let us see the main points of the crystal field theory. So in this, it is assumed that attraction between, that is B by W, you can short form of writing between central metal ligands in the complex purely electrostatic. Next, the mostly transition metal ion to be taken because all the transition metal ion will be having the d orbitals alone because transition metal ions are d orbitals, so it has a 5d orbitals have the same energy is called as a degenerate orbitals. So degeneracy means same energy. So we can have the spherical crystal field will be formed. That is called symmetrical repulsion between a ligand electrons and the d orbital electrons. That is called as a symmetrical repulsion. It forms a spherical crystal field. When ligands are approach the metal orbitals, their electrons will be repelled by the lone pair of electrons of ligands. Now let us see the example, only then you can understand what ligand is approaching the ligand and why they are approaching, why they are repelling, we will see. Now it is d orbital, 5d orbital, that is dxy, dyz, dxz. All are lying in between the axial line. This is axial line, in between the axial lines. Here also in between, here in between. So that is called non-axial orbitals. So the degeneracy, we can call it as a two set of orbitals, T to G. T to G orbitals and EG orbitals. EG orbitals are on the line, on the axial line, the lobes of d orbitals are present. These lobes are nothing but the density of electrons are occupying in this shape, so that we can say as a dumbbell shape. This is called dumbbell shape and XY dumbbell shape in between the axial line. Here also in between the axial line, in between the axial line. So what we can call it as a non-axial orbitals. dxy, dyz, dxz are called non-axial orbitals. That is called T2G orbitals. This is triply degenerate. It is a doubly degenerate. So triple E is called T and double E is called E for a even. So for this is the axial line. So they are called as axial orbitals. Axial orbitals are dx square minus y square and dz square. So only here the electron clouds are forming in a donut shape. This is called donut shape. Just like a cigarette fumes, how they are coming in a spiral form, like that is forms a donut shape. So dx square minus y square and dz square are called as a axial orbitals, are called a EG set of orbitals. This is T2G set of orbitals or a non-axial orbitals. EG set of orbitals or axial orbitals. Electron density present on the axial of the lines. Here in between the axial. Let us see, when a complex is formed, ligands destroy the degeneracy of the metal orbitals. Listen here, this is the metal, it is a vacant orbitals. Empty orbital is having metal. Some electrons, some other p shell and s and sp, and we have electrons. Those electrons will be repelled by this ligand electron orbitals. Ligands are approaching the central metal, the electrons will present in the some other places will be repelled by this. So that is called a symmetrically they are repelled. It is called as a spherical crystal field. That is called symmetrical repulsion. When the ligand approaches the metal orbitals will be repelled by the lone pair of electrons of ligands. So what this is called, lone pair of electrons of ligands are approaching the central metal, they will get a repel now. So now the orbitals have the different energies. The degeneracy will be spoiled because of the ligands are approaching. It degeneracy will be spoiled by the ligands because they are approaching, they disturb the ligand electrons. So this remove the degeneracy of the set of the d orbitals into two sets. That is called Eg and T2G. Eg is called dx square minus y square and a dz square. I mean axial, along the axial orbital. This is a non-axial orbitals T2G in between the axial line dxy, dyz and dxz or zx. Anything we can write it. So how to pronounce this? E and then space G. That is doubly degenerate. And then T2G to say T2G. This is the way of pronounce it. It is a trebly degenerate. In most transition metal complex, either number 6 or 4 is called as a I mean, it is a number of ligands are surrounded by the central metal ion. If it is a 6 means we will say octahedral, 4 means it is a tetrahedral. So what it is, the difference of the energies are called as a 10 dq. It is constant value that is called differential of quantum. It is implying the energy is called differential of quantum. Out of two sets of Eg and T2G will rise into one of the Eg and T2 will be going to the higher energy level or into the lower energy level. It has not been very important when d electrons are very closer to the ligand, I will have a higher energy. When d electrons are closer to the ligand, have higher energy set. So let us see the example. This is octahedral complex. Ligands will have 6 ligands. So it is the energy increases in this way. This is the ground state of the d orbital, dxy, dyz, dxz. And next two set is dx square minus y square and dz square. This is axial orbital. These three are non-axial orbitals. This is 3 or T2G orbital. These 2 are EG orbitals. So after approaching, when the ligands are approaching the vacant metal orbital, they will get a symmetrically, they will get a repulsion, and the degeneracy will be, I mean, same energy will be disturbed and then rise into the excited state. In excited state, the two set of generacies are split into two. The T2G will go to the lower energy side and EG will be raised up. So EG in a raised up and T2G in a ground state. So EG has a higher energy and T2G has a lower energy. This is dxy, dyz, dxz. And this is the energy, this energy is disturbed, I mean, due to the 3 orbitals, it is disturbed, so 3 by 5. And this is disturbed because of this, so 2 by 5. So not for octahedral. So this center is called as a barycenter. Already I told you the barycenter value is 10 dq. So what we are going to see 3 by 5 and 2 by 5 value later on. So for octahedral structure, T2G is a lower energy and EG is a higher energy. In case of tetrahedral compound, either same thing, there's a d orbital approaching the ligands or approaching the central metal. So that ligands are destroying the degeneracy of the energy, immediately will excited to the excited state, and in this excited state T2 will come to the higher energy and EG will go to the lower energy. So what G letter should not come for tetrahedral. In octahedral alone the G should be mentioned. So what I have written here, T2 in a higher energy level, E in a lower energy level. So this is, these three is affected by these two and these two are affected by these three. So what totally 5, 2 by 5 and this is 3 by 5 delta T to be written, T for a tetrahedral complexes. Thank you students. Okay.